Welcome to the Explainer. Today we're doing a threat assessment on a pathogen that's rare, but believe me, incredibly potent. We're talking about Eastern Equine Encephalitis Virus, and we're looking at it specifically through a Dutch lens. So let's just start with a number that tells you almost everything you need to know about the gravity of this virus. For patients who get the really bad neuroinvasive form of the disease, the encephalitis, the mortality rate is about 1/3. A statistic like that, well, it definitely gets your attention. Now, I know what you're probably thinking. This virus isn't endemic to the Netherlands, right? It's not something we see here. So why all the fuss? Why the urgency? That's really the core question we're digging into today. Why is being prepared so absolutely critical for a threat that feels so far away? Well, the answer really lies in how it's classified. It's what we call a non-endemic, high-consequence pathogen. Its virulence is just off the charts, and when you combine that with the real possibility of it being imported, whether through travel or even vectors like migratory birds, you've got a significant public health concern that we just can't afford to ignore. And just a quick heads up, all the data we're looking at today has been synthesized from the latest scientific literature and public health reports. If you want to go even deeper, you can find a full list of our sources in the linked Notebook LM document. Okay, so let's get into the nitty-gritty. To really understand the threat, we have to get to know the agent itself. What exactly are we dealing with on a molecular level? Think of this slide as the virus's passport. It's in the Togaviridae family, genus Alphavirus. That tells us a lot right away. We're looking at a classic Alphavirus blueprint. You've got this enveloped, spherical particle with a beautifully organized icosagal symmetry. And inside, it's packing its weapon, a positive-sense single-stranded RNA genome. Those little E1 and E2 glycoprotein spikes you see on the surface, those are basically the keys it uses to break into our cells. Okay, so let's talk about the human cost. What actually happens when this virus isn't just a silent infection, but really makes its presence known? The clinical picture is really a tale of two completely different diseases. For most people who actually get sick, and that's only about 4 to 5% of everyone infected, it's like a bad flu that goes away on its own. But for a very small, very unlucky group, especially kids and the elderly, the virus crosses into the central nervous system, and that's when things get devastating. For those patients, and particularly for children, the only thing we can do is provide intensive supportive care, focusing on managing things like brain swelling and seizures, because there is no specific antiviral drug that works. And that leads us to a really critical question, right? If there's no silver bullet, no specific cure we can use, how is the Dutch healthcare system actually set up to handle a potential case of Eastern equine encephalitis? It all comes down to what's called a clinical safety net. Here's the thing. When a patient shows up with severe encephalitis, the symptoms look almost identical to herpes simplex virus encephalitis, and that one we can treat. So the protocol is clear. Admit for intensive care and immediately start IV acyclovir to target the most likely treatable cause while the diagnostics are running. And here's the crucial part. Even though acyclovir does absolutely nothing against Eastern equine encephalitis virus, the protocol itself is our best defense. It guarantees that any patient with these symptoms is immediately put on a high-level supportive care pathway. We're talking managing seizures, intracranial pressure, protecting their airway, all the critical stuff. This approach lines up perfectly with international guidelines from groups like the CDC, which also emphasize that aggressive supportive care is the only way to go. And hey, since there are no targeted antivirals, the whole issue of drug resistance, well, it's just not a factor here. All right, so that's the clinic. Let's switch gears and move from the bedside to the lab. What does it take from a public health and biosafety standpoint to contain a pathogen this serious? And this table just says it all, doesn't it? This is serious business. Eastern equine encephalitis virus is a risk group 3 pathogen. In the United States, it's even a tier 1 select agent. What that means is any work with the live virus has to be done under strict biosafety level 3 conditions. That includes any attempts to grow it in the lab, which is usually done on cell lines like Vero cells, where it causes really rapid, obvious damage. And it all has to be handled inside a certified biosafety cabinet, no exceptions. But this super high containment requirement, it actually creates another huge challenge for our national preparedness. And it's one you might not expect. So here's the catch-22. Because it's a select agent in the US, getting a hold of authentic viral strains is incredibly difficult. For labs here in the Netherlands, that's a massive hurdle. It's not just about running one test. It's about being able to properly validate our molecular assays like RT-PCR, creating reliable controls, and participating in international quality checks. Without easy access to the real thing, maintaining our diagnostic confidence and accreditation is a constant uphill battle.
It makes international collaboration absolutely essential.
And that brings us to our final big picture question. We have this robust clinical safety net that ensures top-notch supportive care, and we have the high containment labs. But with these major challenges in validating our diagnostics, is that framework really enough to handle the complicated threat of a rare but incredibly severe imported case? It's the classic tension of preparing for those low-probability, high-impact events.
We hope you found this explainer on Eastern equine encephalitis virus valuable. Please subscribe to our channel for more deep dives into these critical microbiology topics. And we'd love to hear your thoughts and questions, so leave them in the comments below.